Today, I will demonstrate my C++ lab project called Suite++. This project focuses on object-oriented programming, templates, and multiple searching algorithms. First, let us talk about class design. So, let me start with opening up my searchable array, which is a template class. It uses dynamic memory allocation and follows the rule of 5, including move constructors. So, first of all, object-oriented programming is a programming paradigm where we organize our program using classes and objects. So here in this program, you can see that I have a class named searchable array. Each class represents a real responsibility. For example, searchable arrays manages data and search result manages search output. Second, you can see here I have created a constructor and a copy constructor. So, a constructor is a special function that is automatically called when an object is created. Its purpose is to initialize data and members. For example, in this constructor, it is initializing data called other and second thing comes up is destructor. For example, let me open up the other file. So in this code, you can see that here searchable array and it is deleting the data, which is a destructor. So a destructor is a special function that is automatically called when an object is destroyed. Its purpose is to free resources by dynamic memory. So when we use new and delete, that means we are using dynamic memory allocation. So the destructor of this lab is created in searchable array class, which deletes the dynamically allocated array to prevent memory leaks. This ensures proper memory management and avoids resource leakage. Now, let us talk about copy constructors. A copy constructor you can see here in this program, which is a new object which is created from an existing object. It performs a deep copy, so both objects have their own separate memory. Now, you will have a question, why is it needed? Since my class uses dynamic memory, a shallow copy would cause both objects to point at the same memory, leading to errors. For example, if I pass an array object by value, the copy constructor ensures safe copying. Now comes the copy assignment, which you can see here is used when one existing object is assigned to another existing object. It first cleans old memory and then performs a deep copy. You can see here if this is not equal to other, which means other is a copy constructor. So if this one is not equal to the copy constructor, it will delete the data and then again it will create the same size of array which is of copy constructor and add the size and create the size, which you can see from here, which is new, which is used for creating dynamic memory. Now, this allows safe reassignment of arrays without memory corruption. The rule of three states that If a class manages dynamic memory and defines one of the following, destructor, copy constructor, or copy assignment operator, then it should define all three. So in this case, I have used the rule of three, which is I am creating dynamic memory by using new. I am using copy constructor, and again I am using copy assignment too, which follows the rule of three. Destructor frees the memory, copy constructor copies the memory, and copy assignment handles reassignment safely. Now comes move constructor. Move semantics allows us to transfer ownership of resources instead of copying them. This improves performance. The move constructor and move assignment operator efficiently transfers array ownership without allocating new memory. So here is my move constructor, in which you can see that other data and other size, which is the copy constructor's data and copy constructor size, is moved to the other one. So to follow the rule of 5 and make the program more efficient, I have used template. Template allows, which you can see from here, T means template, allows us to write generic code that works for multiple data types. Instead of writing separate code for integers, floats, and string, we use templates.